Hi everybody. Today now we'll be looking at vertical and horizontal asymptotes to each of the following curves. Okay, so let us, before we begin, remind ourselves. Reminder, we say that the line x equal a is a vertical asymptote to the curve y is equal f of x if any of the following holds. We have like six criteria. So the limit as x goes to a minus is minus infinity or plus infinity. If one of these holds, then the line x equal a is said to be a vertical asymptote. So when checking, it's enough to verify that one of these six limit equalities hold. At least one of them holds. Okay, great. So this is when the line x equal a is a vertical asymptote. Example, as x goes to 0 plus 1 over x is 1 over 0 plus, which is plus infinity. So x equals 0 is a vertical asymptote to the curve y equal 1 over x. Okay, let's look at another thing. Horizontal asymptote. The line y is equal to m is said to be a horizontal asymptote to y equal f of x at plus infinity if the limit as x goes to plus infinity of f of x is equal to m, and similarly the line y equal to m is said to be a horizontal asymptote to y equal f of x at minus infinity if the limit as x goes to minus infinity of f of x is equal to m. So to check for horizontal asymptotes, we need to evaluate the limits to find horizontal asymptotes. We need to look at the limit as x goes to infinity of f of x and the limit as x goes to minus infinity of f of x. Of course, I'm assuming that these limits make sense. Okay, now let us move to our examples. So let's start with the first example. The curve y is equal x over x plus 1. Of course, the domain of the function that sends x to x over x plus 1 is just minus infinity minus 1 union minus 1 infinity. And we know that this function is continuous at every point in its domain. So the only possible vertical asymptote is the line x equal minus 1. Let us check whether it's a vertical asymptote. Let's look at the limit as x goes to a to minus 1 plus of x over x plus 1. What is that? So if x goes to minus 1 plus, then x is negative 1. And if x goes to minus 1 plus, then x plus 1 goes to 0 while remaining positive, right? Because if x is bigger than -1, then x plus 1 is bigger than 0. So this is just negative infinity. So x equal -1 is a vertical asymptote to y equal over x plus 1. Now let's look at the horizontal asymptotes. Let's look at plus infinity. So the limit as x goes to plus infinity of x over x plus 1, of course this is an infinity over infinity form, which is indeterminate. So what I can do here is factor out the dominating term, in that case, which is x, and then cancel it out. So get 1 over 1 plus 1 over x, which is just 1 over 1 plus 0, which is 1. And at minus infinity, the limit as x goes to minus infinity, x over x plus 1, by the same argument. I mean, you can notice that the same argument works here. 1 over 1 plus x, which is also 1. So the line y equal 1 is a horizontal asymptote to y is equal x over x plus 1 at plus infinity and at minus infinity. Okay, so here this is an easy example. This is how we should proceed when we encounter such a problem. Let's move on to a harder one. So what do we have? E to the x, e to the minus 1 over x. Let's look at y is equal e to the x. So of course this function is a continuous function. This is defined and continuous. So the function that sends x to e to the x is defined and continuous in R on the real line, which is minus infinity, infinity. So there are no vertical asymptotes. Now let's look at the horizontal asymptotes. So at plus infinity, I have to look at the limit as x goes to plus infinity. Well, let's write the m the proper way, of e to the x, which is plus infinity. So there is no horizontal asymptote at plus infinity. Now what I have to do is that evaluate the limit at minus infinity. Well, this is clear. The limit as x goes to minus infinity of e to the x is 0. Why is that? I mean, e to the minus infinity, this is 0. Of course, I don't like to write it this way, but that's fine. So the line y equals 0 is a horizontal asymptote to y equal e to the x at minus infinity. Okay, so really we have to do both limits. Now, in some cases, the asymptote may be the same, but in one case, we may have a horizontal asymptote at minus infinity, but not at plus infinity. Okay, so it's very important to check both limits at infinities, at minus infinity and plus infinity. And we may have two asymptotes that are different. For example, if you take the line, if you take the curve y equal arctan x, it has two asymptotes. So y is equal pi over 2 at plus infinity, two horizontal asymptotes, and y equal minus pi over 2 at minus infinity. So really what we have to do in such a case is always check both ends, the limit at plus infinity and the limit at minus infinity, of course, if these limits can be defined. Okay. Let's now move on to the other example. I mean, these are pretty easy, I guess. Look at y is equal e to the minus 1 over x. Of course, this function, the function that sends x to the e minus 1 over x, is defined on all numbers except 0. And is continuous everywhere at every point in its domain. So the possible VA, the possible vertical asymptotes, is only the line x equals 0, the vertical line x equals 0. Now, the reason I picked this example is the following. Let me check the limit as x goes to 0 minus, say, of e to the minus 1 over x. Is it e to the minus 1 over x or e to the 1 over x? I don't know. E to the minus 1 over x. Okay, it doesn't matter. It's kind of the same thing, almost. Let me look at e to the minus 1 over x as x goes to 0 minus. What is that? Or let's look at 0 plus. This is just e. Well, this is just e to the minus infinity, technically. Right? Because as x goes to 0 plus, 1 over x goes to plus infinity. So minus 1 over x will go to minus infinity. So this is just equal to 0 since it's equal to e to the minus infinity. So this does not allow me to conclude, is not sufficient to conclude that x equals 0 is not a vertical asymptote. I really have to check the other end, or the other side of 0 to be more precise. It's the limit as x goes to 0 minus of e to the minus 1 over x. Now what is this? As x goes to 0 minus, 1 over x will be minus infinity, right? 1 over x will be minus infinity. Why is that? Because 1 over 0 minus, it's minus infinity. So what do we have here? We have e to the minus minus infinity. So I have e to the infinity, which is infinity. So this limit is infinity. Now this allows me to conclude that the line x equals 0 is a vertical asymptote to y is equal e to the minus 1 over x. I mean, basically, maybe we can try to sketch the curve. Let's see how it looks like. I mean, it's so as 0 plus basically. Oh, I mean, let's look at the horizontal asymptotes first. Horizontal asymptotes, the limit as x goes to plus infinity, or the horizontal asymptote at plus infinity, or oops, I messed it up. E to the minus 1 over x. What is that? So at plus infinity, e to the minus 1 over x is 0, right? 1 over x is 0 if x is plus infinity. So really this is just e to the minus 0, which is 1. And at minus infinity, it's also the same answer, because it's also e to the minus 0, which is 1. So the line y equal 1 is a horizontal asymptote to the curve y is equal e to the minus 1 over x at plus infinity and minus infinity. I mean, let's try to sketch the curve. I mean, this is not a very hard curve to sketch. Now, so at 0 minus, I have a plus infinity limit. And this is the line y is equal to 1. At plus infinity, so let's see, at 0 minus, I have plus infinity. You can tell that, of course, this may not be an accurate graph. And at 0 plus, the limit is 0, so I have something like that. I mean, you can, of course, yeah, well, let's take this for granted. I mean, you can double check this sketch. Of course, it's not a very accurate sketch. We can make a better sketch using more information, but I think this should be fine for now. Okay, let's look at one more. It's y is equal to x squared minus 1 over x squared minus 3x plus 2. I mean, really, this is a rational function. And if I have to solve the denominator is equal to 0, I can factor it out. You know, it's x equal 1 or x equal 2. So this is defined, the function that sends x to x squared minus 1 is defined for x is different than 1 and x is different than 2. So really the possible VA, I mean, you know, a rational function is continuous on every point in its domain. So the possible vertical asymptotes are the line x equal 1 and the line x equal 2. Now notice, let us evaluate the limit as x goes to 1 of this function. Of course, here there is something that we immediately can spot is a cancellation that can happen. This is just x minus 1 times x plus 1, and then you can factor it out into x minus 1, x minus 2. Of course, you can cancel the x minus 1 out, and then what do you get? So what do we get here? We get 2 over 1 minus 2, so we get minus 2. Okay, so the line x equal 1 is not a vertical asymptote, right? We have checked that the limit as x goes to 1 of f of x is minus 2. So the limit as x goes to 1 plus of x squared minus 1 over x squared minus plus 2 is equal to the limit as x goes to 1 minus, x squared minus 1 over blah 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 is equal to minus 2. So this line is not a vertical asymptote. So it's not every point that is excluded from the domain that is a vertical asymptote. You know, the vertical line x equal that point is a vertical asymptote. Okay, now let us look at the line x equal 2. The limit as x equal 2 of x squared minus 1 over x minus 1 times x minus 2. Of course, here the top is 3, right? So I have 3 over 0. So that's very good. Now 2 minus 1. So 2 minus 1 is 1, right? Times 0. I mean, you know, this is here in the context of limits. Now, really, what I have to do is determine whether this 0 is a 0 plus or 0 minus to conclude whether this limit is infinite or minus infinity. Great. Now, really, just if you take x going to 2 plus, so x minus 1 is positive because 2 minus 1 is positive, and just pick that if you pick x to be strictly greater than 2 but going to 2, this is just 0 plus, so this is plus infinity. So this limit is, so the line, this limit is infinity. So the line x equal 2 is a vertical asymptote to y equal x squared minus 1 over x squared minus 3x plus 2. Okay, now let's look at the horizontal asymptote, the horizontal asymptotes. I mean, you know, I will do one of them, and the other one in that case is just the same. But in any case, you should do it. Now let me plug in. This is infinity over infinity, so it's a indeterminate form. Let me factor out the highest power of x on the top and the highest power of x on the bottom. 3 over x plus 2 over x squared. I can cancel the x squared out. So let me do that quickly. So I get 1 minus 0 over 1 minus 0 plus 0. So this is just 1. So the line y equal 1 is a horizontal asymptote at x is equal minus infinity. Is a horizontal asymptote at plus infinity. Now at minus infinity is also the same thing. I mean, I'll do the calculation pretty quickly. In that case, let me cancel an x squared out. I factor an x squared, 1 minus 1 over x squared 1 minus 3 over x plus 2 over x squared, and then cluck, schluck, and then you just get 1 minus 0 over 1 minus 0, which is 1. Okay, so the line y equal 1 is a horizontal asymptote at minus infinity. Now we have one more example. Y is equal to x squared over x squared minus 1. The domain is clearly it's for x, so defined for x different than 1 and x different than minus 1. Really, I mean, the possible vertical asymptotes in that case, this is a rational function, are the lines x equal 1 and x equal minus 1. So let's check here. The limit as x goes to minus 1 of x squared over x squared minus 1. So let me factor the bottom there, just to be sure. So this is x plus 1 over x minus 1. Of course, what do we get? On top we get, this is on the side, we can do these small calculations, minus 1 squared times 0 times minus 2. Okay, so I have a positive number on top. So it's 1 over minus 2 times 0. So all I have to do is determine whether the 0 is a positive 0 or a negative 0. Now if I take x going to minus 1 plus, then I'll be sure that the 0 is positive, because if x is bigger than minus 1, then x plus 1 is bigger than 0. So what do I get? I get it is 1 divided by 0 plus times negative 2. The answer is a negative number, so it's negative infinity. Okay, so let's look at this one here. So the line x equal minus 1 is a vertical asymptote. Now let's look at the line x equal 1. We can do this the same way. X squared over x squared minus 1 is just equal to, I mean, the same thing. I can factor it out. Now here, 1 plus 1 is equal to 2. And 1 minus 1 is 0, and the top is 1. So, I mean, using the same ideas, so the top is 1 squared, which is 1. The bottom is 2, the first term, and the other one is 0. So let's take just x going to 1 plus, then I'm sure that, how do we say it? Then I'm sure that x minus 1 is positive. It going to 0 or remaining positive. So I get here plus infinity. So the line x equal 1 is a vertical asymptote. Now let's look at the horizontal asymptotes. I have to do both limits in that case. At plus infinity, it's clear. I mean, I'll leave it to you to check. By just canceling out the x squared, factoring out the x squared on the bottom, this is just 1. And at minus infinity, and in that case, the answer, as you know from experience, will be the same. We'll not do the calculations. So the line, oops, this is 1 here. The line y equal 1 is a horizontal asymptote to y equal x squared over x squared minus 1 at plus infinity and minus infinity. Okay, so these are some quick examples. I've done them a bit fast, but I think they're okay since you're comfortable with limits now. And thank you very much, and I hope it was very helpful, or I hope it was helpful.